Do you still write by hand? Anything besides shopping lists? A new study looked at what happens in our brain when we write by hand or type on the keyboard, and it makes a really strong case for handwriting. I personally quite like handwriting, and I'm totally convinced it's good for, well, something. So I should be extra skeptical of this finding. But let's have a look. Handwriting is becoming less and less common. A YouGov survey from 2022 found that about 2% of people have basically stopped handwriting completely, and another 3% do it less than once a year. I imagine that's this emergency situation when you really need to write down that clever pun. The survey also found that younger people write less by hand and that women are more likely to write by hand every day. When I was at school, we learned cursive writing first and block letters later. But my children learned block letters first because most of the text they read today is printed block letters. And by now they happily type away on their phones and tablets. What's it doing to their brains? I find this an interesting question because I feel like handwriting is a much more conscious act than typing. If I imagine handwriting a word, I can tell you exactly how to do it. And I can type the same word on a keyboard, but I cannot for the hell of it tell you where the keys actually are. The typing process seems to go through an unconscious channel into the motor cortex. Handwriting doesn't. I find that very curious, and it does make me wonder if we're really losing something by typing. But there are good reasons for this shift from handwriting to typing. Notably, typing on a keyboard is at least at present more efficient and faster. If you want your text to appear in any standard form, either online or in print, or because it's submitted through a digital medium, it makes sense to use a keyboard. There's also the issue that handwriting can be difficult to decipher. I sometimes can't even read my own writing, not to mention that of others. Can you imagine handwritten Twitter? Oh, sorry, I thought you meant extra fries, not exercise. And what does Amazon do with all these supposed signatures they've collected anyway? So maybe complaining about the switch from handwriting to keyboard typing is just good old resistance to change. Like old people were probably complaining when younger people began writing on paper rather than carving stones because, with a pen you don't really build muscles the same way. But handwriting does seem to have benefits. At the very least, brain scans have shown that it activates more brain circuits. Though this isn't so surprising because making more complex hand movements should do that. If you watch this video while I'm speaking, that'll also activate more brain regions than if you close your eyes. But so what? But some studies have found that handwriting helps if you want to remember something. Kind of. For example, a study from 2014 found that students who took notes on laptops couldn't recall as much about their notes as students who wrote by hand on a notepad. In one experiment, they recruited about 100 students in Los Angeles and asked them to take notes of a lecture. They divided them into two groups. One took notes on a laptop, the other by hand. A week later, half of each group was allowed to study their notes, the other were not, and then everyone was asked questions about the lecture. The handwriting students who were allowed to study their notes did best, especially on factual questions. And while that is very interesting, it could well be that students who take notes by hand just tend to be better at note-taking. So I'm not very convinced of the memory benefit, but handwriting has been found to quite convincingly benefit the visual recognition of letters and similar drawings. A meta-analysis from 2022 looked at 50 studies that were mostly on children who were learning to read and write. They found that learning to write by hand had moderate to large benefits when later learning to recognize letters, whether handwritten or not. For example, those who learned handwriting were less likely to confuse letters like D and B. Just why that is so isn't entirely clear. There are two competing hypotheses. One is the perceptual variability hypothesis that hazards that handwriting trains the link between vision and movement so that letters later have a motion aspect to it. The other is the visual analysis hypothesis that hazards that handwriting trains your ability to identify just how a thing is made up in general. For the new study now, they looked at something else. That's the number of connections that handwriting creates in the brain. For this, researchers at the Norwegian University of Science and Technology recruited 36 students and recorded their brain activity with 250 electrodes, while the students were either writing with a pen or typing on a keyboard. They then analyzed the recording in different frequency bands and looked for correlations. The students who were writing by hand showed significantly more such correlations. The researchers argue that these widespread correlations across the brain are good because they are known to be important for memory formation. I find this very interesting, but I also think it's a rather indirect conclusion. Maybe handwriting activates more brain regions because young people do it so rarely. Though I really want to believe that handwriting is good for the brain. Until I stop doing it, then I think it won't be so useful after all. A new study by a group of British geologists looked at how a huge tsunami devastated the populations of Stone Age Britain about 8,200 years ago. Cool. Disaster. Extinction. Can it happen again? Let's have a look. This new research is about a fantastically destructive series of disasters known as the 3 Storegga slides. Sounds like a ride at an amusement park, but it was far from that. The Storegga slides were massive landslides underwater west of Norway. Let's have a look at a map. Norway is here, and Great Britain is southwest of this. The 3 slides happened around here. Geologists believe that they happened in a relatively short period of maybe days or weeks. The Storegga slides are among the largest known submarine landslides in history. An estimated 3,500 cubic kilometers of sediment suddenly slipped underwater. The slides left still visible erosion marks on the seafloor that span 95,000 square kilometers. Scientists still debate the exact cause of the slides. One hypothesis says that it was related to an earthquake. Another is that it was a sudden influx of meltwater from glaciers that destabilized the seafloor. A third is a sudden release of methane from underneath the ocean. And science being what it is, there are probably a few dozen more ideas for what happened, but I think I'll leave it at that. Whatever the cause, the consequences would have been devastating for people living on the coastal regions of Norway and the eastern parts of Great Britain. This is because one of those 3 slides must have caused a massive tsunami. Here's a recent simulation for how that tsunami would have impacted in northern Scotland near Aberdeen, close to a place called Tarty Burn. Note how the water retreats before hitting and then filling up this little stream. This is not a real-time simulation. In reality, this flood wave would have taken about 8 hours to roll in and out. There's evidence that this indeed happened in sedimentary deposits that can be found way inland in the eastern parts of Great Britain and that contain debris from the seafloor. The time at which these deposits have been dated is consistent with the time of the slides. Computer simulations have found that the wave could have reached a height of about 20 meters, and in some regions of Great Britain, it would have reached as much as 80 kilometers into the land. Maybe not so coincidentally, archaeological studies have found that some prehistoric coastal settlements in the affected parts of Great Britain were abandoned around that time. They measure this in terms of dating any kinds of events, such as new buildings or changes in land use, and they saw a sharp decline following the Storegga slides. And that brings me to the new paper, which is about the impact that this tsunami wave would have had on the people who lived in that region at the time. The people back then were what's called Mesolithic hunter-gatherers. Mesolithic means that it was a period in the middle of the Stone Age that was a transition between nomadic and settled lifestyles. At this time, it was still possible to cross over from Europe to Great Britain by land through a region called Doggerland. This region once allowed people to walk over from Great Britain to what's now the Netherlands. Doggerland is today at the bottom of the North Sea, and the Dutch are trying very hard to not join it there. Doggerland should not be confused with Diggerland, which Google helpfully suggested. The authors of the new paper now say that archaeological findings indicate that many of the Stone Age people in Great Britain lived near the coast, where they harvested and farmed seaweed and shellfish, and in the winter they ate a lot of hazelnuts. Because, as the squirrels have also figured out, nuts are very durable and very nourishing, so they make great winter food. Unfortunately, the tsunami would have devastated the hazelnut bushes, so the lucky people who survived the tsunami would have had nothing left to eat for the winter. They would have been forced to leave. The authors also point out that the impact of the tsunami would have been particularly devastating in this region of the world because the Stone Age people living there wouldn't ever have seen anything like it before and had zero warning. This is different to, say, Japan, where they have frequent earthquakes that sometimes cause tsunamis, so they'd have learned to move settlements further inlands. Not so in the UK. They were literally rolled over by this freak event. Could it happen again? Experts say it's very unlikely that another big underwater landslide will happen in that region. The seafloor off the coast of Norway was thoroughly investigated 20 years ago because Shell is extracting gas from down there. They found that the reason the seafloor slipped is that during an earlier ice age, the region was covered with glaciers. When the glaciers melted, they left behind a layer of loose dirt that later caused the slip. A similar event could only happen if there was another ice age. That said, it isn't entirely impossible that other regions will see similar slips or that tsunamis are caused by other events such as earthquakes. This is why every once in a while you'll hear scientists say that the UK needs a tsunami warning system. But the way these things go, people will only listen to scientists after it happens. One of the most disturbing ideas in physics, or maybe the most disturbing idea, is that space can fall apart. That's because it could be what's called a false vacuum. A false vacuum can remain in this innocent, reliable-looking form for billions of years, but eventually a quantum fluctuation could be enough to cause it to decay. This would release enormous amounts of energy and kill all of us. Yes, a cheerful thought. So far, this has all been theory, but a new experiment has now for the first time observed that quantum fluctuations can actually trigger a transition like that, luckily not for the entire universe, but for a small and safe test setting in the laboratory with ultra-cold gases. Let's have a look. You'd think that empty space is about as boring as it gets, but the question of just what it means for space to be empty is more difficult than you might think. You see, physicists believe that our entire universe was in some sense created from empty space. And if the empty space which we find around us now is not a true but a false vacuum, then it'll eventually decay too. These vacuum decays are similar to phase transitions that we can observe in nature around us. A good example of such a phase transition is chemical hand warmers like this one that I dug out of my children's room. These hand warmers contain a liquid which is supercooled with a thin metal plate in it. That it's supercooled means that it's at a temperature below its freezing point, yet it isn't solid. Such a supercooled liquid contains energy that it wants to release by switching into another, more stable solid state. You can trigger this transition by a large enough perturbation, for example pressure or a small electric spark, by twisting this metal plate. The liquid then suddenly makes a transition to a solid and the energy is released. This makes it warm up, which is why the thing is used as a hand warmer. In physics, a state that isn't totally stable but kind of stable until you disturb it too much is called metastable. It's nothing to do with metaphysics, I swear. Maybe they should just have called it kinda stable. Metastable states are like teenagers, basically. Just fine if you leave them alone, but if you disturb them, weird things can happen. What happens with metastable states is often summarized in an energy diagram like this. The vertical axis is the energy of the system, and the horizontal axis is some parameter that describes the phase transition. You could think of fluid stuff to the left and solid stuff to the right. This upper valley is the metastable state. You see, if the system is perturbed a bit, it'll roll back into the same valley. Disturb it too much and it'll roll over into this other valley. Normally, such phase transitions are caused by external forces, but theoretically they can also happen by quantum fluctuations, in which case the system tunnels from the metastable to the stable state. These quantum fluctuations need no external cause. They just happen all by themselves. It's God rolling dice, as Einstein put it. And this is one of the theories for how our universe might have been created with all that stuff in it. Once upon a time, there was a force vacuum. It decayed and released a lot of energy that turned into matter. Some billions of years passed, and now there's us, the leftovers of that energy from the force vacuum. Now you might think that if our universe was created by vacuum decay, then it can't decay again. But it isn't that easy. You can easily imagine there being a sequence of these metastable states. So maybe our universe will decay again. Physicists believe that this would happen by a process called bubble nucleation, in which a quantum fluctuation triggers the decay in one place and then it spreads to neighboring places. All of this is theory, mathematics, and equations. So far, no one has actually seen a quantum fluctuation trigger such a phase transition or a bubble nucleation. And this is now what the new paper is about. They didn't look at vacuum decay, but a phase transition triggered by quantum fluctuations and the bubble nucleation. For this, they used a cloud of sodium atoms cooled to near absolute zero and put it into a magnetic field. The sodium atoms have spins and they want to align themselves along the magnetic field. They also want to align themselves towards each other though. This creates a metastable state in which the atoms are all aligned in the same direction, but not ideally aligned with the external field. Increase the strength of the external field and they'll start flipping. They don't flip on the borders because the magnetic field is weaker there. And this is what they observed. What you see in this video is the transition from the metastable phase that is blue to the stable phase that is red. You can see that there's actually some oscillation going on and a kind of anti-bubble in the bubble that forms. What does that mean? It means they have confirmed that these theories of quantum-triggered phase transitions are correct, and they also measure the dependence of the probability of the decay as a function of the energy. They're now planning to do more experiments, but don't worry that they'll accidentally destroy the universe. I think it's very unlikely. Google has unveiled a new artificially intelligent system, alpha geometry, that can solve problems of mathematical geometry. It's the first computer program to surpass the average performance of participants at the International Mathematical Olympiad. That might sound like an incremental improvement, just one more thing that AI is really good at, but mathematics isn't just one more thing, it's everywhere. This makes Google's recent development a significant step forward. Let's have a look. This new research was done by scientists at Google DeepMind and Google Research and just published in Nature. They tested their new program, Alpha Geometry, with a set of problems posed at the International Mathematical Olympiad during the years 2000 to 2022. After the program was trained, it was given 30 Olympiad geometry problems. The AI solved 25 of them correctly within the standard Olympiad time limit. This performance far surpassed the capabilities of the previous state-of-the-art system, which could only solve 10 of these geometry problems. To put this into perspective, the average participant at these Olympiads solves about 15 problems correctly. A gold medalist typically solves almost 26, so the new AI is better than the average, but not quite beating the smartest of the smart humans. Clearly, this AI is doing very well, but how does it work? Alpha geometry uses what's called a neurosymbolic approach. That means it combines a neural language model like ChatGPT with symbolic deduction like that used by software like Mathematica. The neural language models are good at identifying general patterns and relationships in data. This makes it possible to quickly come up with potentially useful ideas. These symbolic deduction programs, on the other hand, basically allow to infer logical relationships. The combination of both makes for a very, very powerful system. It's indeed much more similar to how the human brain works than just neural networks, because it combines intuitive ideas that we extract from input with more deliberate, rational decision-making, similar to Kahneman's System 1 and System 2 thinking. It's like basically alpha geometry has what ChatGPT is missing. It understands logic. One of the problems that have so far prevented AI from becoming good at maths in general, or geometry in particular, is the lack of training data. There are only so many proofs that humans have written down that you can train them on. The Google researchers have addressed this by first generating a vast pool of synthetic proofs that added up to as much as 100 million examples. Thanks to this, alpha geometry could train without relying on human demonstrations. Better still, alpha geometry doesn't just spit out a result, it delivers a human-readable step-by-step proof. Basically, it works by trying to find a sequence of steps that logically fits together and that also solves the problem. Though it isn't irrelevant to mention that most of the proofs it found were considerably longer than those from humans. But the significance of alpha geometry's achievement goes beyond solving geometry problems. It generally highlights AI's growing ability to reason logically, discover new knowledge, and verify solutions. And not only this, it can also explain how it arrived at a conclusion. Such a type of AI system has uses that extends beyond geometry. Not only can this achievement be generalized across various mathematical domains, but it'll without doubt also come in handy in other areas where rational thinking and logical deduction is of use, like everything. Now throw in a bunch of data in addition to the reasoning skills and you have the perfect scientist, unbiased, clear-headed, able to digest huge amounts of data and draw logical conclusions from it. That alpha geometry is able to explain how it arrived at a conclusion should also help alleviate the fears of people who think that AI will be a black box that no human can follow. You see, the thing with mathematical proofs or arguments in general is that it's difficult to come up with correct chains of reasoning, but once you have the proof, it's much simpler to check whether it's correct, though simpler doesn't mean simple. These developments in AI also raise an interesting philosophical question, which is whether there's anything humans can do which AI will not eventually also be able to do. At the moment, the major protection for jobs from being taken over by AI is that a lot of human labor requires sensor input or physical skills that robots don't have or AI can't cope with yet. Because robots are developing incredibly quickly, and if you combine this development with AI, there really won't be much left for us to do. Maybe we'll all just make YouTube videos. Well, actually, Google is also working on a text-to-video system that isn't yet publicly available, but from which they shared some amazing examples last week. So soon enough, I can replace myself with an AI, which will make total sense because all my viewers will be robots. We've seen a lot of headlines in the past year about how dangerous AI is and how overblown these fears are. I found it hard to make sense of this discussion. If only someone could systematically interview experts and figure out what they're worried about. Well, a group of researchers from the UK has done exactly that and just published their results. What they found is not very reassuring. Let's have a look. This new report is based on several rounds of interviews with 12 experts on software development using what's called the Delphi method. The Delphi method is named after the Oracle of Delphi, a position held by a priestess in the Greek city of Delphi around 2,500 years ago. The oracle's task was to supposedly convey messages from the gods about the future. The Delphi method was invented by the American non-profit RAND Corporation in the 1950s to make better use of experts' knowledge. It works by conducting in-depth interviews with the experts. The interviews are then transcribed and anonymously shared with the other participants. They add opinions on each other's interviews and further information. Then another round of interviews is done. This process can be repeated several times. The Delphi method has become a common way for companies and committees to leverage expert knowledge and convert it into actionable plans. And that's what these researchers also did. They asked a lot of questions about what would happen in software development by the year 2040 and eventually identified 5 points on which the experts more or less agreed. The first one is that they all agree that by 2040 corners will be cut in AI safety. But interestingly enough, they think it's not because of competition between companies, but because of competition between nations. In particular, they name the United States and China. The results are summarized in this chart where blue means agreement, orange disagreement, and white means no opinion. 2 of the experts said that by 2040 AI will cause events with at least 1 million deaths. That's a megadeath. Yes, Megadeath is actually a unit, not just the name of a heavy metal band. You can also see that several experts disagree, but this is partly because they think it'll only be a few thousand deaths. Another thing on which the experts all agree is that by 2040, quantum computing will only just be used. Again, you can see that some of them disagree, but in the text it's explained that they disagree by degree. In that one could say quantum computing is already being used today. It just has no commercial relevance, and that's not going to change by 2040. The next point of agreement is that almost all of them are worried that AI will make it increasingly hard to tell apart truth from fiction in various domains, from written text to image to video, and that it will likely come to an arms race in which some AIs produce fake content and other AIs will constantly try to identify content as fake, quite possibly sometimes accidentally flagging the truth as fake. It'll be a mess. One of the participants summarized it like this: "We're not going to be living in a George Orwell world. We're going to be living in a Philip K. Dick world where nobody knows what's true." And just in case you're too young to remember, Philip Dick wrote a bunch of dystopian future novels in which his characters frequently question the nature of reality, the most famous probably being Do Androids Dream of Electric Sheep, which was later adapted for the movie Blade Runner. Now, those 3 points I basically expected to see, but the last 2 I found somewhat of a surprise. The experts all agree that by 2040 it'll become common to buy and own internet assets by way of tokenship. A tokenship is basically a digital record, and it's what NFTs have become known for. Even more interestingly, they don't think that this tokenization will happen through blockchain technology, but through other distributed services. According to one of the interviewees, blockchain has now proved its irrelevance. And the final item is that they think the increasing complexity of software in general, and that of AI in particular, will make it hard to tell apart accidents from deliberate manipulation, basically because no human will be able to really figure out what's going on. Modern day Kafka, basically. The experts also came up with a bunch of proposals for how to address these issues. As you'd expect, they ask for regulations on AI safety and more built-in safety requirements and outcome checks on software development. This is what's listed here as ambient accountability. They also ask for better education of people in relevant positions and more input from the social sciences on what the impact of all these changes might be. These are surely all good ideas, and they'll surely be pretty much ignored. I'm confident these experts know what they're talking about, but I think they have somewhat of a blind spot in an area that I care a lot about, which is scientific publication. AI is going to make it dramatically easier to produce rubbish papers and fake data and spread them all over the globe. In fact, I'd bet it's basically happening as we speak. This falls into the general category of fake news and misinformation, but I'd argue it's an underestimated special case. That's because fact-checkers heavily rely on scientific publication, and if that base erodes, the entire house will tumble down. So yes, interesting times ahead. Maybe we'll soon find out whether androids do dream of electric sheep, and if they do, whether that makes them vegan.